Good evening, everyone, and welcome to today's session hosted by SAR Education. My name is Diksha, and I will be your moderator for this event. We are happy to welcome all of you here to learn about use of maths manipulative in the foundational years. Today, we have Ms. Saira, who will be sharing her knowledge and experience with us during this session. Before we begin, I want to go over the session's rule. We'll put everyone on mute except for our speakers to avoid any disruptions. We will disable the chat box, so please write down all your questions at the end, and there will be a 10 minutes of questionnaire session. Then we'll enable the chat for everyone. Please stay until the end. As we all know, there is a 5 minutes of assessment that must be completed in order for you to obtain your certificates for this webinar. We also want to make sure that you have an interactive session, so please don't hesitate to participate and ask questions. Few information I'd like to share with you all about our speakers. Ms. Zaira is a certified trained teacher in early year curriculum from Lambeth University of Teacher Training School, UK. She's a certified concept-based inquiry curriculum professional. She was recognized and awarded as the Best International Coordinator for Embedded International Dimensions in School Curriculum for 2017-2020 and 2019-2021 by British Council. She was also awarded as a change maker under the Empowering Teacher category by CED India in 2023. She has been associated with education for more than 18 years. I will now turn the rein over to you, Ms. Zaira.
Thank you, Diksha. I hope everybody is able to hear me.
Yes.
Okay. So one thing that I want to encourage all educators over here, principal, teachers, or any parent who is just a part of this session, I would like you to make the maths visual for the children. Hello, I'm Zahira Sheikh, an academic excellence manager and STEM coach. And today we all are going to look at the importance of visuals in maths and how beautiful and powerful these manipulatives are to building fluency and confidence among the children, right? We all have seen children memorizing the steps, right? And maths facts to solve multi-digit problems using a traditional way, or you can say the algorithm that looks very easy, but then you just change a little bit that question, they get lost. They are not able to solve those problems. As per our assessment criteria, what we think that if a person, whether it's a child or any elder person also, if they are able to solve maths problem very fast and with accuracy, we think that he or she is fluent in maths, right? But as per me, not is just for me, but if I take any example from our real life also, it's just not about maths or any subject, whether it's English or any language. If you just take any example from your own daily life, you will find that what are the things that you are fluent in, right? And what are the things that you're not fluent in? Just think one example. So here I would give my own example. If I say myself, I'm not at all a fluent chef. Although I can cook very fast, I cook delicious food, right? I can read the recipe and I can cook very fast and I know each and every ingredients in that particular recipe. But still, I'm not that fluent chef who can just modify the ingredients and who know that, okay, if I just change a little bit of this ingredient, or if I just change that ingredients, I can make so much of tastier things out of this recipe. So it means if you want to have fluency in any activity, you should have the other components apart from the fast and accuracy in that. That is nothing but the flexibility. How flexible I am to thinking that situation and solving that problem. right? Am I able to think that situation or connect that context with the knowledge that I've acquired by following some rules or any steps, right? Okay, so how that flexibility we can develop among the learners while they are doing mathematics problem, right? So what happened when they see or they just observe a number, that number does not give any visuals to them. If I say 9, I don't have anything much about talk about that number 9. But if I have a visual to say, visual to look at, I have a lot of things to talk about that number. So I'm not taking much time of your, and I'm just going to hop my screen to another screen because I want you to visualize the things, not me all the time. So let me share my screen, and I'll just going to talk about the usage of these manipulative and how we can change the abstract concepts of mathematics into concrete, pictorial, and abstract. So today I'm going to use a virtual manipulative site, that is Mathigon Polypad, right? The link for this site will be shared in the chat box. So anyone can just use this site to explain or practice the mathematic problem solving questions, right? So here you will see a lot of manipulative names have been mentioned. Like I can just scroll down here, you will see that number bars. Number bars are nothing but the manipulative kit that we have given in pre-primary sections, that is number rods, right? Then number frames, this is nothing but the 10th frame that we have in our kit, right? Then we have number cards. Again, these are the part of our kit, manipulative kits, the number cards. And number lines are nothing but the representation of the counting beads that we use in our classroom, right? And then a lot of things are there which we use and we have already provided in our manipulative kits. So this site can be used by the teachers, parents, or the students to understand the mathematical concept and the visualization of the numbers, right? So if I say I was talking about number, right? So I will take the example from number frame, that is number 10 frames. Okay? So I'm just going to tell you first of all, like what is the number I'm talking about? It's 9. Okay, if I just tell you 9, okay, yes. So if I write 9 over here, so just a sec. Yeah. So what do we have to say about this 9? I don't have anything to visualize. I do not have anything to talk about this number. I just say 9, there are 9 fruits, or there are 9 toffees, there are 9 chocolates, there are 9 pencils. That's at all. After that, I'm not able to make any connection or any relation between the number of this 9. I don't have any sense of this number. I cannot visualize this number. But if I use any manipulative, and I'm going to use this 10th frame for this. So this 10th frame is nothing but a 10 frames are there where each row has 5 frames. If we put the counters in that frame, that the numbers are, that we can count the numbers. The empty frames represent nothing. But if we put the counters into it, it represents the 9 numbers. So if I just fill this frames with counters, I am able to visualize my number 9, right? Okay. Now, this made number 8, and now this is 9. So I can say about this presentation that I have 5 dots on first row and 4 dots at the below, right? But if I just change the counter of this, it is quite clear to me now. Okay, I have 9 counters, but the combinations is different, right? I can tell you now, this 9 is nothing but the combination of 7 and 2. What made me say that? Just because of this number, I am able to say that this 9 has 7 and 2 as its part, right? Again, if I change this color of this counter, I can again tell you, okay, this 9 is again, I can decompose into 4, 5 or 4 or 6 and 3, right? So now I have lot many things, lot many explanation for this single number. Now I know that 9 is just not 9. It can be represented as 5 and 4, 4 or 5, 3 and 6, 6 and 3, right? Or I can say that, okay, 9 is 1 less than 10 as well. If I put one more counters in this tens frame, I would be able to turn this 9 into 10. So see the power of visualization and the manipulative, where the children are really experiencing that number. They're making sense of that number, right? Just memorizing the concept, just memorizing the steps doesn't make them fluent in mathematics concepts, right? Once you will make them understand 5 and plus 4 makes 9. And after that, if you just ask them, okay, whenever you have to find 9, you can have the bigger number in your mind and then count on the smaller number. That is a fixed process that we want our children to memorize. But if we have this kind of exercises in the class, which is nothing but the representation of single number in different combination, it gives them a clarity about a number. And from their memory, they can pull out the combination or information wherever they're required, right? Because when we want them to use these numbers in number operation, they need to know how I can break a number into pieces, or how I can regroup a number into tens and all, right? So what other activities we can do using this tens frame? So first of all, the representation of a single number using two different counters, right? So I can find out how many different parts I can break this number into. So I have already done it, and I just want to share. I would share this screen with you. So you will be able to see clearly that how many different possibilities are there to represent 9 for my children. So now there is not a single part they can say, but they can talk about a lot of things, a lot of explanation for this, and they can compare also, like how this number representation of 9 is different from this, right? And this can be represented or through a picture or drawing using colorful strips like this. And this is nothing but the visualization or the pictorial representation for the number rod. So this tens frame also can be replaced with this kit, this number rod, where the child is able to pull together the two combinations, two number rods to make the whole. And this is nothing but the you can say the basic of the fraction that the child is going to learn in their coming years, right? So today I'm just talking about the foundational age, like from K to 2, how children are like benefited with these manipulative to build a maths competency, right? So this is 9, only number 9. So here it is also clear that how many different combinations they can make for a number, right? So this is one thing, decomposing a number, making part, representing a number into part, whole, or making number bond, or we can say this is nothing but the addition fact of all the addition fact of your number 9. So this manipulative, suppose if you are using in a like a group of 25 students, so you can divide the class into two groups, and you can just give them few tens frame and ask them work in group and represent the numbers. And once they are done with their representation, then they pose questions to reason their combinations or their work that they have done. Do not leave the class as whatever you have instructed the students to do, and after that just leave it by saying that, okay, you have done well or very good. But yes, after that, you must include a question like, how did you do that? Can you tell me more about the combination you made and how your combinations are different from the other group as well, right? So I'm talking about these numbers, but we make sure by using this process so that child can develop a sense of a number, and they're going to use in addition form as well. Suppose now I want my children to do addition, add these numbers, right? So I have 9 and 7. So what we have learned when we were children, right, student, then our teacher used to say that whatever the number you have, just try to memorize or keep the bigger number in your mind and count on the smaller number. That is again just a step that you want your children to memorize. They are not going to become fluent if you just give them this instructions to follow. You just ask them that they have already aware of the combination that they can make for 9, and now they have to represent both the number, and then let them think how differently they can represent this number. So again, they will pull down and fill this frames with counters to represent the number. So I have this 8 counters, and now I have 9. And very next tens frame, they have to have how many? 7. So it's their choice how they want to represent. It's not hard and fast rule for them that they have to fill the upper row with 5 and then the bottom with the 4. It's not that. It's their choice how to do that. But yes, they must complete one row to move out to the next row, right? Okay. So this is my 9 and 7. Now they know when we have discussed or introduced the number using this tens frame, they had a sense of this 9 number, that if they put one more counter, it becomes 10, right? So now they are very much like aware how they can make it 10, and they can make it as a 10 complete frames, which is nothing but unitization, right? Unitization is a process where we teach students to count numbers in groups, and how this is a very essential part of your counting, right? So now I'm able to tell you that what is the number it becomes just because of this visual, right? I can say this is 10. Actually, I not need to count it one by one. So I just know that from my tens frame, that first row has 5 and the second row has 5. Altogether, it's 10. I not need to count it literally, right? So this is my 10 and this is my 6. So I can say that 9 plus 7 is nothing but 10 and 6 together, it makes 16, right? So how beautifully the child can group or make a group of tens, right? And this can be represented through other manipulative as well. So when I'm going to use another manipulative, so that time also I'll share how this grouping and regrouping becomes very much important for them to solve problems with carryover or like borrowing sums and all, right? Because they have a lot of questions when you ask them to carry one number from right to left place value, or just borrow from left to right. They have a lot of questions to that, right? And when we ask the students to solve any questions, we have a habit of asking answer. What is the answer of this, right? Can you just tell me the correct answer? But for the small children, especially for pre-primary and grade 1-2 teachers, if you put just this question instead of asking what is the answer, if you ask them what is the story, so if you ask this, what is the story, they start thinking for number of objects for these abstract numbers, right? And when they have the visuals in their mind, they can represent the number very, very easily, right? And when you ask them, what is the story? Very next moment, you need to add another question, that is, what does it look like? Because when they are handling the concrete object, they must be able to represent in a pictorial form. It means they should be able to represent through pictures, right? So if I want to represent this tens frame calculation in the form of picture, so how I'm expecting from my children to draw it? So I am expecting that they can draw it like I have this 9 number of chocolates or number of toffees, whatever the story they can make, they can just represent it through picture. This is nothing but bar model, maths model, or tape model, whatever model you just say. It's just give them an idea what I'm doing with these two different numbers, what I'm doing with this two different quantity, what I'm doing. I'm just pulling them together. So 9 and 6. So I don't know what is the total, right? So I need to know the total. So if I need to know the total, the children need to understand that I have to put them together, right? So it is quite easier for them to explain what exactly the operation I'm following using my model. So I am just adding both the numbers. And in same way, if I'm just asking them the next question, so I have 9 toffees and 7 toffees were eaten away, right? Or taken away by my siblings. So how many toffees are left with me? So in that case, again, the child can just represent 9. So this is my 9, and how many I have taken away? 7. So they have a clear understanding, a clarity about the visualization. So I have to take away 7 from this 9. So I am left with how many counters in that particular 10 frame? So I have only 2. So how I'm going to represent this operation in my modeling, this presentation? So I know I have a whole number like 9 toffees, and from that 9 toffees, 7 were taken away. So I will represent this as 7, and I don't know what is left with me. So this would be my representation for my this concrete operation or the presentation. So this shows that I know the total that I have, and there is some change, whether it has been taken away or added into my whole. So what is left behind, what is extra from there? So that is how the child should be encouraged to represent that concrete operations or concrete manipulations that they are doing using this modeling, right? Okay, so this is how we can do addition, subtraction, or number representation for any number. And this is just not the end of the presentation. Even we can ask them to compare the numbers as well as arrange the numbers in ascending and descending order, right? So there are a lot of things we can do. Suppose, again, I'm just taking one more examples from this use of this tense frame. Subitizing. Subitizing is also one of the important and essential element of number sense when we are introducing number to the children, whether they are in pre-primary or primary. The number should be introduced or subitized as per the level of the children. So if I ask my children, what number does this represent? Just a sec. Do not see there. Just tell me. Okay. Just look at this part and tell me what number these dots represent. So for that, I am expecting my child to give an answer without actually counting it, but my child is going to count one by one and then give you the answer. But subitizing is a thing where the children can give you the number without actually counting it. But how I'm going to develop that skill among the children? So for that reason, we have to represent, or we have to give the number in such a combination or such a group way where children are able to guess the number without counting them. So this is random presentation of a number. I'm not able to guess instantly. I have to count all of them. But if I represent using this tense frame, it is quite easier for me to understand these are 5. I'm not going to count for each and every counter. I'm just telling you 5, right? This is called subitizing. If I just give you one more set of tens frame. Yeah. See, if I have another tens frame like this, yeah. So I have, how many are these? If I just give you this visualization for a fraction of second and then just remove this from your screen, then how will you just tell me that how many counters did you visualize? So you will make some connection what you have seen on the screen, that okay, the first row had 5 and then again extra at the bottom, it makes 6. So here again, the next element the child is going to use from the number sense, that is spatial sense. They are making sense of this space that the this counters covers, right? So, and if you just ask the children to tell you the number about this, they are also going to tell you, yes, it's 4, because they have a habit of seeing this number in dice, right? They can see, they can make the sense of this space, that okay, 2 counters on the top and the 2 counters at the bottom, all together they make 4, right? And see, this random counters were not able to visualize, or you can say the counted or guessed by the students. But if I place these counters in a such a way, in a pattern where the child can make sense of this space, right? So if I present like this, right, and then ask them what is the number, can you subitize? So they again, they can make sense of the spaces the dots are kept, and they can tell you that I can see 3 dots as like vertically, and then 2 and then 1, altogether 6. Or they can visualize that I can see 3 dot horizontally and then above 2 and then again 1. So this is nothing but the visualization of the child, or understanding of the child, how they are seeing this dots, the presentation of this dots, right? Suppose if another child can say, I can visualize only 4 dots as I see in any dice, and 1 extra at the bottom and 1 extra on the top. So how the flexibility is developing in my classroom when I'm posing questions, when we are talking about that number, we are not just covering the counting syllabus in my class, I'm just talking about the numbers with my students. So this will develop the flexibility in their thinking, right? Okay, so subitizing, counting, comparison, and then arranging the numbers in ascending and descending order, and finding the relation between 2 numbers, addition, subtraction, and even we can use multiplication as well, if we are able to, like if we are using this tens frame in our like grade 1 and 2 as well. So in that case, when we put more than 1 dots in one frame, suppose if I put 5 dots in one frame, and like 5 rows, 5 frames are covered with 555, it will be easier for them to use the memory that they have learned in the nursery or the KG, that first row have 5, and if one frame has 5 dots, altogether 25 dots, right? So this is how they're going to use the known information from their memories. They're not memorizing the step, they are understanding the concept, and they are going to use these information when they are going to do the one step ahead problem, right? So till for this manipulative, if you have any doubt or any question, so you can pose. Meanwhile, I'm just taking the screen to the other manipulatives. Anyone, if you want to know more activity using this tens frame, you can ask. Otherwise, I'll just move to the next, that is base 10 blocks, or you can say number tiles or cubes over here, or Dean's block, as we have given in the manipulative kit, right? I can see one. Any question? Okay. So So in number, first of all, I would
Zara ma'am,
try to,
there's one
yes,
question.
Yeah.
There's one question in the chat box.
Okay.
Yeah.
How should we add 20 plus 2? So in that case, the child need to understand that 20 means I have to use 2 complete frames. Just a sec. Right? Yeah. So they know that this is nothing but 20 means I have 2 full tens frame, right? Both the frames are filled with my 20 counters, right? Yes. So this is my 20, sorry. Okay. Then to drag all the way down. Okay. Okay. I'm just removing. Okay. 20 plus 2, right? So this is how they are going to write 20 first. And if I am, if my children don't have the tens frame with them, they can just draw these circles the way I'm just dragging these circles into the frames. The children can draw these circles in a frame, right? This is my 20. Now, if the child has only 2 frames with them, they understand that I don't have more frames to count the counters or fill the counters. So they have to draw another one, right? And they know that until and unless we fill these frames with counters, I am not able to count anything. This is nothing but just the blank frames. There is no numbers. So now they know 22. 20 and 2 makes 22. And if you have this like answer in the class, next moment you need to ask, what is the story? So let them think that I have 20 toffees in my right pocket and 2 toffees in my left pocket. Altogether, I have 22 toffees. And again, you ask them, what is the model? So they can say that 20 and 2 altogether makes a whole, that is 22. And then again, you can ask, how many tens and ones are there? Now, this is quite easier for them to visualize the number of tens that they have and ones as an extra, right? So they can say, I have 2 tens, complete tens, and 2 extras in it, right? And again, if you want to ask few more questions of critical thinking, you may ask, okay, how many extras are there in more than 20? To make it more than 20, how many extras are there? There are 2 extras. Okay. How many more do you need to make it 25? So they can easily tell you that I can see 3 empty frames on the top. So if I fill with again 3 dots, it will become 25. So it's quite easy for them to visualize a number, to make them understand one more than the number or the one less than the number, right? How bigger this number is from the previous number, or how smaller number is this from the upcoming number or the successor. So what are all these? These are nothing but the essential part of your number sense, elements of the number sense. When you are having the counting quantification in your class, do have this kind of questions, do have this kind of number talk to introduce the number and give them the visualization for sure. Okay, so shall I move the next slide? Okay, I hope I was able to solve your query, ma'am, give you the answer correctly. Okay, now cubes and tiles. Okay, so now I'm just taking this cube. Okay, let me introduce first. If you are using this first time, so this is my smallest unit of base 10, that is unit block. And this is my tower of 10. This is nothing but the compilation of, you can say, the combination of all the 10 units blocked together in a tower. And this is my flat square of 100 units, or you can say the 10 towers of 10. So first of all, the child need to understand how these numbers are represented and how many units or tens make these numbers, right? So this is what we are developing, the flexibility of that particular number representations, right? And here I would like to add one more important thing. Until and unless your child is like proficient to understand and quantify the numbers, do not introduce the counters or abacus in the class, because they are still learning and understanding the number. They are making sense of number, like they are understanding the quantification of number. But if you use abacus in place of this star, one as a one bead, and again 1 unit for 1 bead, they will not make any sense. They won't be able to make any difference between these two different representations. So it's my request to not introduce, at least when your children are struggling or they are learning the quantification. Why? See, if I tell you this is 1 unit, okay, I'm okay with this. If I tell you this is 10, but until and unless I'm able to show you how this is 10, see, they can relate. This is unit block. And if I just make a tower of all these 10 units, it become a tower of 10, right? So this is the important part of the combination and their visualization, which we should encourage them to see and use in their quantification. So now see how beautifully I can show them that this 100 flat square 100 is nothing but the 10 towers of tens. And if I break this into more tiny part, I can break it into 100 units. So this is how they have a clear picture about the numbers, right? And it gives them the flexibility. When you ask them, see, you don't have the bigger number to subtract, then you have to borrow from your hundreds place or tens place, and we ask them to write 1 over tens or 100, it becomes very confusion for them. Why I'm borrowing 1? So this is how, if they have a practice of representing a number in different combination and different representation, it will be easier for them to use that concept, right? So I make myself more clear with few examples, right? Few activities and examples. Okay, so I have one number, right? It's 68. Now I'm taking like considering grade 1 students, where they need to represent a 2-digit number and they should have a clarity about tens and ones. Okay. So now I know that 68, which is nothing but 6 stars of tens. Okay. Four, and then 6, and I have 8. I have 8. So this is my 68. This is one of the representation that I can make from my known experience, right? I know that 60 means 6 stars, but if a child wants to represent in different combinations, they also can represent. So I'm the child who wants to represent 68 like this. 4 towers of tens, and then I want to represent this 20 in units form, and again this 8 as a unit. Now I can say, just a sec. Okay. Okay. Group and then copy. So one child represents 68 in the form of tens and ones. There are 6 tens and 8 ones. And another child represents 4 towers of tens, 4 tens, and then 28 ones. So the child is able to see or visualize that number in two different combination, right? And both are correct. I cannot say this is not right, but very careful. Very next day, the child will have a question, ma'am, how to represent it. If I'm writing here, just see the question from the child side, that if I'm writing this is 6, 10, 6, and this is 8, so this is nothing but 68. But if I write for this, how I'm going to write this number? 4, 2, 8. Is that I'm going to write for this number? So what answer you're going to give at that moment? Because again, if I'm asking them to visualize the numbers as a whole and write the digit for those numbers, so they are right. And at the same time, if my another child is representing the number in this combination, so what I am expecting from my child to write like this? Or this is 20, so 4, 20 and 8. Is that we're expecting? No. At that moment, we need to make them clear about the misconception that whenever we count a number or represent a number, it should be represented in groups. Wherever the possibility is there to make the group, you need to count those numbers into group. That is nothing but unitization of that number. So that moment you will say, can you make these 20 unit blocks into group? Yes, I can do. So do it and then represent, right? So this is how they will understand. So whatever the number I'm representing, it can be represented in smallest unit and the biggest unit. But if I'm watching that number at a particular frame, or I'm writing that number in a quantification form and representing with a symbol, so I have to make sure that the number has a group. That number should be counted in group. That's how the child understand. If I need to count a number from 1 to 10, I have 10 groups. And if I'm counting from 1 to 100, though, I need to count the numbers in tens. So that is nothing but the benchmark numbers for the students to count a number in groups, that is 5 or 10 or 100, right? And this is again another element, important element of number sense that they need to learn while you are introducing the number, right? So see, this is the understanding or the memory that they are going to use when they are doing the number operation. So this is my number representation. Now I'll show you how these knowledge the child will pull down from their memory to solve a addition or subtraction problem, right? So I'm taking this number only, 68, and plus 5. Okay. So now I know that 68. Okay. 68 is nothing but 6 tens and 8 ones. Okay. So this is my 20, and again 20, 40, and then again my 60, right? I'll group them out here and drag from. Okay, this is my 60, and I need to have 8. So now I know from my experience and the practice that this 10, if I remove 2 from 10, it will become 8, right? And I'll represent this as 68. Now, how many more do I need to add? 5. Okay, so I'm bringing in 5 more counters here, right? So this is my 5. Now, the child need to understand, I need to represent a number in groups. So if there is a possibility to make groups, so I have to first make groups and then count all together. So I know this is my 8, and if I pull out 2 counters from here and group it into group it into 10, it will become 1 rod, right? 1 rod of 10. Now, how many are there in all? So I can see that 6 stars and 1 10 stars, 1 stars of 10. Altogether, I have 7 stars of 10s and 3. Altogether, I have answer is my 73. Right? Yeah. Okay. So this is how I'm going to use my understanding of decomposing a number or making groups into, right? And suppose this is my addition sums, right? Now I want them to solve a subtraction one, right? So I have 68, right? And I want my children to subtract, okay, subtract 9. Okay, right? Now, if they have smaller number to subtract, it's quite easy for them to just subtract your ones from the ones and tens from the tens. But if you have bigger number at one's place than the smaller number in the big number, so you have to think how I'm going to do that. So first of all, again, represent 68. So my 68 is this. Now I have to subtract 9, but I don't have 9 blocks over here. Then what I need to do? I need to regroup any of these tens block. Okay, so I will just pull out one unit, 1/10 rod and split it into 8, 10, and I'll group it with this 8. So now I have 18 ones or 18 unit blocks. Now it's quite easier for me to subtract 9 out of these 18 blocks. So I can just strike out or just remove the counters. I can strike out or remove the counters. So I'm just striking it out. So 8, 1, and then this 2 or 2, 4, 5, and then 6 and 7 and 8. Now, how many are left? So there are, I have 5 10 towers, right? Towers of tens, that is 50. And I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I have 59 numbers. So this is the manipulation with the manipulative. They are handling the manipulative, but if I want them to represent this picture or this operation, so how I'm expecting my children to represent? So again, they have to think over their own operations and they will find out. So I had a whole number that was 68, but I took away 9 out of it. So this would be the representation for this question. And I don't know what is left with. So if I have this kind of representation, this is nothing but the part whole or the number bond or the number facts, addition fact the child has learned in their previous classes. So if I have the whole number with me and I know one of its part and the another part is not known to me, it means I have to subtract the first number from the whole, right? So again, this logic or this exercise, they are pulling down from the previous understanding or the information they have learned while representing the number into different two combinations, right? Okay, this is addition, subtraction. So do you have any questions still here so that I can start with the multiplication division as well? Okay, 6 stars of tens, 8 ones, 5 ones, 7 tens and 3 ones. Okay, yes, yes. Okay. So these are the things where children get the understanding about a number as well as the flexibility of thinking happens, right? They are just not following an algorithm. Okay, you need to count the smaller number on the number line on your finger, or keep the bigger number in your mind. It's just not that. Whatever and whichever the strategy they are feeling is comfortable with them, they can do it. Here you see they can use another strategy as well. If they have, see, 68 minus 9, they can make sense for this number 68, where exactly this number is. This is less than 70. How many more you need to make it 70? More 2. So they can pull out 2 from 9, or they can take extra 2 for the 68 and make 70. And now they can subtract the 9, or they can make easier for them to make these two ones similar. Suppose 68, right? How many more do I need to make it 9? 69. I need 1, right? Now it will become 69. Now it is quite easier for me to subtract 9 from this number, isn't it? Right? So I have 60, but I have already taken 1, added 1 in my number. So I have to take out that number from this. So 60 minus 1, it's quite easy for me to subtract 1 from any number. So it's just 59. See, this strategy is nothing but compensation, you can say, taking 1 or giving 1 away. Right? So this strategy can also develop if they have the clarity about the number, the representation of that number, how they can manipulate those unit blocks or tens blocks into different groups, and they can play with the numbers and they can come up with the answers. There's not only one strategy to solve any question. They have a lot of different strategies to solve, and that's what we want our children to learn, not just one algorithm, steps to follow, but yes, how differently they can do. And this will happen if you have lot of manipulative usage in your maths classes, along with your number talk, right? Along with the critical thinking questions that you put after they solve, they come up with the questions. And do not hesitate to appreciate the mistakes in your classroom. If you have any mistake in your classroom, any error in their questions, do not hesitate to talk about. Ask them to how they do it, how they have worked that out, what make them to solve that number like that. So from their own mistake, they will learn to rectify those mistakes, right? Just let me clear this out. Then I'll take the example of multiplication and division as well. Because most of the time, the students get a lot of confusion in multiplication and division. And we do teach multiplication and division from grade 2, right? Single digit number, long division, we say, or just find out the quotient on the remainder, we do teach in grade 2, right? So how we can use this manipulatives to teach them the concept of multiplication and division? They have learned it in their previous classes as group, right? If I would have asked my grade senior KG student or grade 1 students, can you represent this number into different combinations? They could have shown me as like all the 9 units, or they could have shown me as group of 2, right? They could have represented this number as like this, right? See, this is again a decomposing a number into different combinations or different units, right? So see, one of the children can have represented this 10 into two groups of 2 into 5 groups, right? I have 5 groups of 2. This is what? This is counting in groups, but same time they are learning making groups and the basic concept of multiplication. So this knowledge they have already had from their nursery or KG. So now here, when I'm introducing multiplication in senior, like grade 2, so I need to ask them, what is the product for this number? Suppose I'm just giving them 7 multiplied by 3. So again, instead of just asking them what is the answer or what is the product, ask them what is the story. right? So they can tell you, okay, I have 7 boxes and each box has 3 toffees into it. So how many toffees do I have in all? So this story, they should visualize these abstract number into form of any concrete object, right? So now I know 7 groups are there and each group has how many blocks? It's 3. Okay. So let me represent this. How many groups? 7 groups. Okay. So 1, 2, 3. I'll make a copy out of it. And 6. And I have another one, 7, right? And each group has how many blocks? 3. Okay. So I need to copy this and represent this abstract numbers statement into visualization, right? Visually, I'm representing these number statement, right? So this is how, okay, copy. Yep. Okay. And then again, next copy. Oh, I made one extra group. So I'll just remove this 2 blocks from here and just see how many are there in all. Right? So now this is easier for them to count. So there are 7 groups with 3 object in each group. Maybe at this moment, they are not able to count all. They have already placed all the cubes in form, but maybe they are not able to count it properly because we have already told them that whenever you are going to represent any number, you need to make the unitization should be done. So now they have to make a sense out of it. Okay, I have 21 unit blocks, but how I can represent this 21 unit blocks into groups and extras. So they know that 10 unit blocks makes 1 tower of 10. So they can represent this 21 into 2 tenths tower of tens with and 1 extra. So they can visualize the same product in 2 different ways. And this is nothing but the basic of array representation that they're going to use in their third onwards when they're going to use these present representation to show how they can multiply 2-digit or 3-digit or multi-digit numbers in a form of array or your area model that we are going to talk about tomorrow, right? Okay, so this is how I'm teaching them multiplication using the manipulative. Now I can teach them division as well using this manipulative. So if I just flip the question, yeah. So I know my product is 21, right? Okay. Yes. But if I just change the question that I know the product, right? But I don't know, and I know the number of groups as well, but I don't know how many objects are there in that group. I don't know what is the group size, right? So again, how I'm going to represent that? So just let me reduce it. Okay, delete. So I have 21. This is my representation for 21, right? Now I need to divide these 21 blocks into 7 equal groups, right? I have to represent this into 7 equal groups. So now I need to regroup this tens. I cannot break it without regrouping this to 20. So I need to regroup it. So I have to regroup, split this number. Just a sec. Okay. So I'll just regroup, split this into ones, right? So now I can make first 7, 3, 4, 5, right? 6 and 7, right? So I can make 7. Now I know that I need to divide rest of these unit blocks or tens block into this 7 groups to making it equally divided, right? So I'm just putting one by one the blocks here. Okay, I don't know what is the size of each group is, right? I don't know the size, but I need to know that. So I'm just, again, I don't have unit blocks, so I need to again regroup it and I need to arrange this. What exactly I'm doing, what strategy I'm using? I'm just trying to give away the numbers or the blocks from the whole, right? I'm just subtracting, right? Just see the strategy I'm using. I'm just subtracting the blocks from the whole to divide or the share these numbers equally, right? See. So now I can see, so I have 7 groups and each group size is of 3 unit blocks. So I can write here 3, right? So see how impactful these visual representation is, where the child is able to visualize and see these numbers, these abstract numbers, right? So once you get the answers, you should not forget to ask or add this question: how did you do that? What is the strategy that you used to get the answer? And what is the story of your number statement? Do not forget to add these questions when you really want your children to be fluent in their mathematics problems solving questions, right? So any questions still here? Which part you want me to explain more? Hema ma'am, could you please elaborate? This multiplication or division? Division. Okay. So I'm going to take another example. And this time I'm going to take long division. Okay. This is the basic of my division, when my child is learning to share equally by using the strategy repeated subtraction, right? So now I want my child to be proficient in long division. Okay, so I have 15 which should be equally divided or shared among 2 groups. Okay, now what we have learned from our own experiences, that if I have smaller digit, so I need to take the bigger digit. Okay, that's what we have learned and that's what we follow, right? But we forget when we are talking about the number, the value of this number, but not the digit. This is 15. This is not at all 1. If I'm going to represent this 15, how I'm going to represent? I'm going to represent like this. This is my 10 and this is my 5, right? And then 5, right? So visually, I'm able to see that 15, this 10 is always bigger than 2. Then why should I take the other digit 5 as well? Why? We fail to give this reason to the children, right? Because if I have one tower in the place of tens place, I'm not able to divide this 10 tower until and unless I regroup into ones. See, if I regroup into ones, so what number do I have now? I have 10 unit towers, 10 unit blocks, and 5 unit blocks. Altogether, I have 15 unit blocks. This is how we consider 1 and 5. This is not 1 and 5, but 10 and 5 together, 15 ones. So we consider that we need to divide this 15 into 2 groups. And this is not 15, this is 15 unit blocks. So when I can see 15 unit blocks, now again, I will use my known knowledge that I can divide or share any number into small groups by taking away 1 by 1 or 2 by 2 blocks from that whole. So again, I'm just pulling out the unit blocks. In how many groups do I need to divide? 2. So I had just made 2 different groups, and I'm just removing or taking away unit blocks in groups of 2 from each of this, right? Because I don't know. I need to know what exactly the group size is. I don't know. So I'm just using my like knowledge or understanding from my previous class, that my teacher told me that when you have to share equal share, you need to subtract from the whole equally. So now I can see that each group has how many blocks? 7. Right? Each group has 7. So I can write 7 on the top. That would be my quotient. But be careful while writing the number. I'm not dividing or sharing this 15 units into tens. It's ones. So I have 7 ones. So we have a habit of writing tens and ones. So we should be careful writing these digits, what exactly this means. It means I have 7 unit blocks in each group. So I have altogether 14. But I can see that I have one extra unit block. This is nothing but my remainder. Now this is very much clear to me how and why I need to take this 15 altogether, right? And how this 110 is regrouped into ones, and why I need to take both the digits to divide by 2, right? So any other question? Three digit, okay? You want me to explain 3 digit, but I don't think so. Grade 2 have 3 digit questions. They have only 2 digit number. Never mind. Can we take it tomorrow? 3 digit number, multi-digit numbers, because tomorrow we are also going to have the session for the preparatory level. This is for grade foundational level, like from K to 2. So we can discuss that in tomorrow's sessions. Apart from that, any other thing you want me to share? Diksha, is there any other question?
No, ma'am, I don't think so. But we
Yeah.
can wait for 2 minutes.
Sure, sure, sure. So I had these questions like practiced, you can say, like we can use this to explain the students for the 2-digit addition as well, or the one missing number, how I'm going to identify or find out the missing number in my addition sentence. I have not yet started the subtraction, but yes, from like if I really want my children to be fluent in math, so they should be able to flexible in thinking. They should be able to identify the change in that addition sentence, or just not कि मैंने तो अभी पढ़ा ही नहीं है, मुझे कैसे पता? I have just learned to add both the numbers only. But if my children are learning addition, they should learn how differently I can add, or I can find the components of the like addend of a sum, or how I can find out the change in a sum. That is also important part, right? Okay.
Zara, ma'am, there's one question from Silky Nagrat. So she's asking, manipulators are really wonderful, but kindly tell how can we indulge the whole class in these manipulatives along with the worksheet in 1 or 2 periods a day?
So it's my suggestion, ma'am. When you have like you conduct one introduction, first initial stages should be taken with the manipulative. When the students are able to visualize or understand the concept of that number process, or whether you are teaching addition, subtraction, or quantification, whatever. First, if the children are able to see that number in different contexts and they are able to manipulate that number well, fluently, then you can just ask them to solve the questions from the worksheets. It will be easier for them to solve independently. You not need to focus on, you not need to make them solve the questions and spare your classroom time. It's not that. If they are fluent, if they are flexible in thinking, they are going to solve by themselves. You not need to worry about that. So first, suppose you have to plan your lessons. If I'm going to have multiplication in my classroom in grade 2, and it has 5 to 6 concepts to talk about, right? And then, so take one concept at a time, and then just let them handle those number operations with the manipulative first and represent using the pictures. And when they're comfortable, then give them the worksheets. If you give them in between the worksheets, you think ek part kar liya and then just do the worksheets. No. Let them understand the concept properly and then introduce the worksheets. It will not consume much of your time. Right? I'm not talking about just multiplication. So multiplication have 3 different layers to teach, right? So first of all, they need to find the product. And the next one is the multiplier. And the third one is the multiplicand. When they are able to find all these things by themselves, visualize themselves, then you can just see, give them the worksheet to solve. See, in NCF document is also one thing is mentioned, that releasing the responsibility to the children, right? So first of all, if you find that your children's level is not that level where they can visualize these numbers in different combinations, so you take the first step and demonstrate them how you can represent a number in different compositions, right? Combinations. And once they understand that combinations, then give them to different numbers to identify or represent or compare, and then introduce the number operation to them, right? So this is what first stage should be. I do, you watch, or you see, right? Yeah, you observe. And the second stage should be we both or we all together do, right? And the third part is now you do, I watch, I observe, I assess, I assist. That should be your last part, right?
So, ma'am, I don't think there are more questions for you.
Yeah. So can we start with the questions? Assessment, yes.
Okay. So we will now conduct our assessment round. But before that, I want to say thank you so much, ma'am, for such a wonderful session. You provided such a lovely response to each question.
Okay. I can, sorry to interrupt, Diksha. I can see Ruheen Hassan has a question. Any trick to solve word problems? So again, I would mention over here, please do not search for a trick, but yes, for a strategy where the children can use their own trick, right? So yes, how to solve the word problems, we do have that strategies and tools also to teach the students, but not today. It won't be possible for to have everything in one day, but yes, sure, and we are going to come up with another webinar where we are going to talk about the word problem statement sums as well. Thank you. Thank you.
Thank you so much, ma'am.
Thank you.
We look forward for the session tomorrow.
Yeah, sure.
Thank you. So now I'd like to introduce Ms. Akita, my co-moderator for today's evening. She will instruct us all on how to conduct the assessment. So over to you, Ms. Akita.
Good evening, everyone. I'm sending you the link for the quiz on chat. Please click on any one of the links and it'll take you to the chat, to the quiz. Please enter your email ID. Once you click on the link, it will ask you for your email ID. Please click on it because we need your email IDs to send you the certificates. Please click on any one link and you'll get the quiz. Once you've done the quiz, you can leave the meeting. Thank you so much for joining us. Both the links are same. They will lead you to the same quiz. Kindly take any one of the links and do the quiz. Please leave the optional nickname empty. You don't need to write anything in it. I've sent the links again. If they're not loading or if they're not opening, maybe there's an issue with the internet connection. And yes, you will be receiving a certificate within 7 to 10 business days.
Ma'am, it's working. The links are working.
Yeah. The links are all working.
There might be an issue with the people on phone.
There's no attendance form. You just have to do the quiz, which will mark your attendance. So once you enter your name and then you move forward with the quiz, the first thing it will ask you is your email ID. Once you enter your name and move on with the quiz.
Miss Alka, there's no attendance form for this webinar. You just have to attend the quiz.
Once you're done the quiz, you can leave the meeting. Thank you.
So once you're done with the quiz, you can leave. Thank you so much for attending the webinar.
So for this webinar, you will get your certificate within 7 to 10 business days. You will be emailed the certificates within 7 to 10 business days. If it is not opening, are you on your mobile phones? Because there might be some problem in opening the links on your mobile phone. Kindly save the link and open it on a laptop or a desktop, please. Once you're done with the quiz, you can leave the meeting. Thank you for joining us. If the quiz is not opening, you can always save the link and try to attempt the quiz after a while. So the certificate for this webinar you'll receive after 7 to 10 business days. Once you're done with the quiz, you can leave the meeting. Thank you for joining us.
Thank you so much, everyone, for coming for this webinar. We will see you tomorrow. Have a good day. Bye-bye.